Okay, let's start. Good evening, dear friends, dear guys. Please switch on your web camera, and let's start our additive manufacturing studies. Good evening. Hi. Okay. Today we will continue to discuss additive manufacturing technologies and the industries, the area of application of this so exciting and attractive technology. What do you think about this new type of technology? Does it can change our future manufacturing or maybe our social life? Maybe we can explore the space or can implement only in everyday using goods. What do you think about the future of additive manufacturing?
I think it saves time of production. The time it takes for a manufacturer to produce or model an item, it usually takes a lot of time. But with this technology, it's really fast. It speeds up manufacturing process,
Okay, thank
and
you.
it can also be used to fabricate or make very complicated designs.
Maybe other opinion about the future of manufacturing technology?
Yes, I will think that it will be much more common in everyday use and also for manufacturers. And I think that it will be the most common manufacturing tool in future.
Okay. And what about your opinion, Julia? Okay. I would like to show my presentation for today. Okay, let's start. What about the trends of additive manufacturing? I think everyone know that we can buy 3D printer and install it at home and printed everything that we want to have in our houses. It's sometimes meet customer demands, the demands of our market, yes, and connection with personalization, customization, and increasing the added value for our customer. What about the trends? First of all, in the today conditions, yes, it's some pandemic, specific situation with our health and care. The most popular trends and direction for additive manufacturing application is medicine. Yes, for healthcare, for wellness, and for adopt 3D printing technology for printing medicine devices. The next trends, the next direction, the area or maybe industry, it's automotive, yes, because we can create a customized, a commercial parts, goods for automobile, for different vehicles. For example, we can produce new type and new design of car components, yes, and increase the functionality. For example, it reach speed up to 500 kilometers per hour. Why we can improve these products and the features of our products? Because we can use a new material. Yes, for example, titanium for automobile industry, and increase some mechanical properties, its connection with material. So because titanium powder and thin walls can achieve ultra thin parts, and parts which can make your device, your component more stronger for out conditions. For medical applications, yes, we can print some dental implants and the prostheses for children, for old people, and we can make some reanimation devices. For example, the masks for today, yes, it's the most popular goods which we can produce by 3D printing. What about the another trends? It's for customization, yes, and we can use this technology in fashion, for example. Yes, we can print the dress or modern shoes, which will be the most famous and popular in beyond young people. What about the sport and design? Famous company Nike printed their own design of shoes, foods for football games, and I will show in the video how they can utilize this technology for commercial design and for increase the profit from this production. What about there's some types of bikes and vehicles? Yes, yeah, we can use carbon fiber thermoplastic composite and produce very light and strong strength without assembly and significant weight reduction with our vehicles. Yes, and you will see this example how the company Superstrata produced the first e-bike which has not spare parts. It's one assembly bicycle which produced by 3D printing from the new type of materials. It's thermoplastic, which consists of carbon fiber material. What about the another applications when we can build not only product by design and produce, fabricate a new material? It's advanced material. Yes, we can produce composite material and fiberglass board, for example. Yes, it's the first organic structure for modeling and manufacturing customized and commercial boards. What about aerospace? Yes, last year ago, it was the first place for trends implementation additive manufacturing in aerospace because we have some benefits in weight reduction and decreasing the cost of production and reduce the manufacturing time for prototypes. A new design of space launch vehicle or small satellites, or maybe to produce a liquid rocket engine, for example, with specific nozzle, crucial nozzle, yes, which can work in at high temperature. Because we use specific materials, it's a heat-resistant material, for example, Inconel alloys, yes, and we can make some specific design such as cooling channels with some spiral components, which produce using only traditional technology. It's impossible. Yes, that's why we use a new techniques for production such as additive manufacturing. And next, we should look a video. And I need... yeah. Okay. And I think we'd like to discuss this part of the video and a briefly summary about this video. What we can summary. First of all, it's a wide range of industries and applications area for 3D printing and additive manufacturing. Yes, from medicine to aerospace. We can use the different types of materials from plastic to biomaterial. Yes, we can produce the right shapes and geometries. We use less materials and can produce faster. For example, prototypes and some samples for tests. First additive technology was developed in 1980. Yes, and the annual growth of additive manufacturing or 3D printing market is approximately 20%. But we have not only benefits and advantages of this technology. In some industries, additive manufacturing not so efficient as traditional technology, yes, and the cost of this production higher. It's more rich production. For example, if we produce some mass goods, yes, it's mass production and the large scale of manufacturing. What do you think? Additive manufacturing is the opposite of traditional technology, or it can some further development, or maybe some hybrid technology, and we can combine 3D printing and traditional technology, conventional technology. Additive manufacturing is the opposite, or it's some continuous of traditional technology? What do you think about this thesis? For my opinion, yes, I think we can combine traditional technology. Yes, traditional technology, some cutting, milling, CNC machining, injection molding, for example. Yes, casting, when we form the part, the product by cut or casting material. And I think the future for manufacturing and for different industries, it's combination. First of all, we can produce some raw material, yes, some blanks by 3D printing, yes, maybe for prototypes or some form for molds, for molding. And then we can use traditional technology such as CNC machining for make our surface more clear, yes, and increase the accuracy of our production, of our product. It's some combination if we would like to produce a precision part, a precision goods, yes. But if we talk about some fashion and sports and customization, we can use only 3D printing, yes, because we can imagine, design and produce what we have in our mind. Okay, what about the next question for you? What do you think, or what makes additive manufacturing or 3D printing so attractive for these industries, for medicine, for aerospace, for automobile industry? What make this technology so attractive, so exciting, appealing? What do you think? What is the main benefits, the key factor of implementation?
It gives the possibility to make a prototype so quickly. If you CAD model it and print it, you get the real life prototype really quickly.
Another guys, what do you think? What is the more attractive for you if you are constructing
I think
design? Yes, please.
I think the ability to make complex design and look at them physically. is one ability.
Okay. And right, for what for me attractive, first of all, it's a possibility to produce some very important and crucial parts for aerospace, for precision industry, yes, which produced by traditional technology, it's not impossible, yes, or very expensive, for example, and we spend too much time for product, such as liquid rocket engine for aerospace or gas turbine engines. Yes, it's the possibility to produce very critical or crucial parts for industry. The second attractive factor of additive manufacturing, it's utilization less material, because we can organize a very ecological, maybe, yes, economical manufacturing process. And we reduce the time and sometimes cost for manufacturing process. We can reduce and waste when we manufacture our products. And we can make a free form for customization, yes, for designers. It's three key factors for additive manufacturers, which attractive for me as a designer and additive manufacturer technologist. Okay. What do you think about the revolution? Yes, you know that we are standing near the fourth industrial revolution. Yes, it's digitalization. And what do you think? Is the 3D printing is a revolution, or it's not revolution? Maybe it's became the revolution of an industrial revolution. What do you think about 3D printing? I think it's a revolution in industrial, and because we can change our manufacturing process, yes, we can eliminate extra operations in manufacturing process, yes, we can exchange some traditional technology such as casting or CNC machining, yes, and we change our supply chain. We make our products and goods more attractive and more value added for end customer. Yes, that's why our customer pay less than they pay years ago. Yes, because we change the manufacturing supply chain for our customer. I think it's the core of industrial revolution, when we change one technology by the second types of technology. Yes, it's the future of our manufacturing process, because we can produce not only and for use products, yes, such as medicine devices and engines. We can produce some material product, yes, for example, for 4D printing, when we print and programming our material during the process of manufacturing. That's why we can produce new types of products. And last questions about what do you think about additive manufacturing? It can change our future or not? Change or not change our future, these types of technology? What do you think? For industries, for medicine, for aerospace, some engineering, I think, what do you think? And later.
Yeah, it will change for sure.
Yes, it has changed. It has changed the industry already.
Yes, I think so, because in Russia, in many companies, we have 3D printer for make some prototypes in order to check our solutions, our ideas, and verify our 3D model in order to produce good for using, yes, for industry applications. Okay, let's continue to see videos, and you will see the most attractive example of additive manufacturing in automobile industry. It will be Bugatti automobile components. Technology to use selective laser melting, yes, metal powder and laser beam, optimization of design products, we could reduce the weight of this part, and moreover, not only produce and test this device. I don't remember the name of this component of car. But this car component was tested in Bugatti test bench. You see the topology form in order to reduce the weight. Why we would like to reduce the weight? Because we would like to increase the speed. Yes, it's important for aviation and for cost formula. Yes, because we need to reach more speed, more efficiency technology for be the first on this. That's why we use, first of all, new material, It's titanium because it's a lightweight material. And this material can work in a high temperature because the speed of utilization is so high that the temperature is increasing. That's why we need to use titanium. Titanium is the most difficult to cutting material in traditional technology. That's why we use additive manufacturing. Все? Так, и вперед, да?
Через это. Не надо здесь ничего нажимать. Пошла.
Опять, да, такой? We have some problems with our computer. Всё? Сначала? Опять так. Где? Так, дядя. We need to some 5 minutes for to solve the problems with our computer. Yes, I'm sorry. We win the computer and we can continue our presentation. And what about our agenda and program? For me, as I told you, yes, the most important and attractive for additive manufacturing is ability to produce complex shapes. Yes, it's a possibility to produce some crucial parts. It's a complexity. Yes, the first key factors. What about the economical aspects? Yes, we reduce the number of subcomponents, yes, and eliminate some spare parts. That's why we can reduce the number of operations. That's why we can reduce the time of production. And of course, in general, it's customization. Yes, the possibility to produce individual personal parts for commercial or everyday utilization products. What for me, I think these types of technology is so flexible, yes, because we can use only one equipment, for example, 3D printer, yes, and produce different products. from medical devices to spare parts if we would like to repair our bicycle, for example, yes? Or we can produce some engine for unmanned vehicle. What's the future of this technology? Yes, because it's not so exciting and positive for today implementation. Yes, what we need to do for further development in this technology. We would like to make research, yes, and develop some in-process monitoring. For example, in order to control and inspect the process during this process, yes, in order to not produce some defects after printing. We need to develop new inspection devices for measure and control the precision, the accuracy of our production. It's of course some digital software for pre-modeling and control some part direction or part orientation before printing, because it's very important, and I tell you further why it's so. What about some digitalization? Yes, we can organize and open some digital store, yes, and a digital supply chain, because it's a good opportunity to organize local product just in time. Yes, we can buy, for example, in our region, several 3D printers for different application. Yes, and organize and open local production just in time. We can send order by email for this smart additive manufacturing factory. Yes, and get our product by some days. And the further development and the further trends, it's standardization, because we need standard of this technology. It's very important for aerospace application. Okay, what are the main 5 industries for particular implementations in which additive manufacturing can transform their production productivity? What do you think the first? Aerospace. Yes. Why? Because we can produce complex consolidated parts, yes, with good mechanical properties, and we have some economical benefits in when we reduce the weight, yes, and we reduce the time of production. We reduce the weight, that's why we can increase the velocity, the speed, or we can use extra place in our launch vehicle, for example. Yes, you know that in launch vehicle, it's very important to reduce the weight of parts which we go launch to the orbit, to the space. And this is very important to aviation, yes, that's why we use some topology optimization components of our aircrafts and engines, if it's possible. The second, medical. Yes, what about medical and why? Because we can produce some functional prototypes for education of future doctors, yes, and some devices which can save our life, for example, yes, and in some specific conditions that we have today, such as pandemic, yes, and COVID, we can print some devices hands-free, for example, yes, for not touch some surface and not connect with other people. And of course, we can print some surgical instruments for doctors, for medicine, and orthopedics prostheses for medical application, which is individual for each patient. What about the third industry? It's transportation, some activities, yes, because we Of course, produce lightweight components, yes, which are more efficient and can become mass customization products. And we can produce spare parts in single part, yes, and eliminate or reduce the time for assembly. Another industry is energy, yes, and it's about some gas turbine units for or gas, oil, and energy industries, because we can produce some components such as turbine nozzle, combustion chamber, component of these parts of engine which produce the energy, the electricity and heat, for example, yes, for some fluid aggregates and gas aggregates, because we can redesign some specific shapes and introduce some channels in order to improve the productivity and the performance of these components for energy industry. Another industry, it's customization, yes, parts for customization, and it's about the fashion, the artists, their designer, the local designer, and some marketing. Yes, for example, if you have some a project and you would like to make your first prototype MVP, yes, you need to make it at that's why you can use 3D printing in order to make your first prototype and demonstrate this result, your idea, in metal, in plastic, in some biomaterial, for example, to your investor. This is some example how we can improve the productivity and the performance of our industry. It's some gas liquid aggregates, yes, and last time I told about this company which they first in the world used 3D printing, selective laser melting, yes, produced by metal powder, this type of aggregates. We reduce some volume, the mass of these components, these parts, yes, and we make more flexible design prototypes for this product. Okay, I would like to tell you about the first company. It's a FIT Additive Manufacturing Group. It's located in Germany, and it's first company in the world which implemented additive manufacturing, selective laser melting, and equipment of SLM Solutions Group in their factory in order to produce some commercial products. What about the technologies? Yes, they have three positions of their markets and their activities. First of all, it's make prototype. Yes, if you have some concept idea, you can produce your functional prototype. It's some pre-production, for example, yes, to demonstrate your prototype to your investor or the head of department, for example, yes, to prove your idea. It's for prototyping. The second sphere of application, it's design and manufacturing, when you need to use some engineering tools in order to change your design, change your geometry and shape, and you can produce some component. Yes, it's the same mass production, yes, when we have some volume manufacturing. And the third direction of this company is research and development. For example, if we would like to develop a new 3D printer, or would like to develop a new process to improve our process, for example, to increase the productivity, to increase the speed of sintering of our powder, yes, and for example, to use a new material or produce material during the melting. Yes, when we combine some programming devices and metal powder. They have some specification and standardization in these fields. In which industry they are working? It's for aerospace, automotive industry, and medical technology. What about kind of production? First of all, it's engineering and additive manufacturing. If you would like to change the form and to check some performance of a new product, yes, of a new design. Second, if we would like to make working parts, yes, for example, volume production, yes, it's additive manufacturing workshops. When they produce spare parts on demand, yes, if you send by email, for example, the 3D model of your parts, yes, on demand, they will print them. And for quality agreement, yes, it's for example, for medical technology, for medical application, yes, if you would like to produce final part, yes, check the quality and have some send not only a part and corresponding passport of this component which produced by selective laser melting. We should have the certificate of powder and the certificate of technology. That's why we can combine material and technology together and produce quality agreement for medical utilization. What about the volume manufacturing? Yes, if we have sustainable technology, yes, we can produce a volume manufacturing, it's mass production, yes. For additive manufacturing, for selective laser melting, it's mean that we can produce many parts, multi-products production as a one building platform. Yes, if we can pack more parts in one building platform, it's more economical. And some customization volume manufacturing, if it's for some designers for sports and fashion, for example. What about the workflows of additive manufacturing? It's very important for you because next time you will realize all of this business process. Yes, first of all, it's pre-processing. Yes, when we can transform 3D model from CAD software to a specific software of 3D printer. Yes, we should check these data. Maybe sometimes we can repair because we use the different CAD software and one software for printing. We need some data orientation because build orientation, part orientation, it's very important for quality. It's concern support generation, yes, because you know that we have some overhangs surface on the part. We need to make support structure in order to melting these high parts. It's some job placement. It's mean that we need to pack our products in the building platform and some setting of parameters, of technological parameters, which is the main important parameters for SLM, selective laser melting. It's the laser power, speed, yes, laser speed, hedge distance, and And more information you will learn in your master class with our specialist in selective laser melting. I think it's some layer thickness. I think it's important parameter because we can control the speed of production, yes, the velocity of production, and the quality, the accurate of and precision of our part. And slicing, when we modeling layer by layer, metal powder sintering. Yes, of course, we need to use some quality systems, yes, and in feed they are use FMER, failure mode and effect analysis. When we control and analyze some failures during the process and change our input data in order to correct our process and get more effective output parameters. The next step of this workflow is the processing. Yes, it's the main process. It's very favorite for engineers, for designers when machine is working and you can do what you would like to do. Yes, but you need to prepare your machine, start printing, and then you need to only monitoring the process. But when you finish print, you need to remove extra material, yes, extra powder, and separate your products from the building platform. What about parameters? Yes, which we can control in this process. You will learn further in a master class when you prepare some files for printing. And what about post-processing? It's some control operation, yes, to measure main parameters, geometry parameters, the quality parameters such as roughness and hardness, yes. And if we need heat treatment for heat-resistant material, we realize heat treatment in oven. Part separation, support removal if we realize heat treatment, because if we need to include heat treatment in our processing, yes, we put the building platform with support structure and part in oven. After that, we need to separate and remove support and separate our parts. We need to verify the parameters which we have in which we have after printing, yes, and we have before printing in the modeling step, yes. If you would like to make our surface better, for example, yes, and more accurate geometry and forms, we use milling. After that, we need to realize some measure in order to control the quality and the accurate of our production. What we need to do if you would like to develop additive manufacturing? Yes, it's some we need to realize first of all additive design, because it's very important to change, redesign our product for this type technology. We could not only press the button and load a 3D model file and print them. We need to design a new product. And new, it's the mean after engineering, some engineering tools. What the first? Yes, if you would like to use additive manufacturing, you should think additive. What does it mean? Yes, it means that you should know about the limits, the limitations, constraints of this technology, and the benefits. For example, you have idea of some devices, mechanism, yes, and you know how does it work. And you would like to produce this idea, your innovation, for example, yes, you have some input data about your product. You know the material, yes. For example, you know the functionality the behavior of your product in some condition. And what else you should know about your product? The specific parameters, for example, for utilization. Yes, some critical maybe or crucial parameters for these parts. After that, you need to realize some additive engineering. Yes, because your production should be economical. Yes, you need to minimize your production cost and the time of production. Yes. What about the cost optimization? First of all, it's connect with some design optimization. Yes, and design optimization is connection with some additive parameters, additive activities. It's a build job. If when we allocate our product on the building platform, yes, and set some orientation, position, when we pack our building platform with our products, with our parts. What about wall thickness and support? Yes, if we will print wall thickness, we will reduce the mass. Yes, we can weight light components manufacturing. And if we would like to reduce support structure, yes, we need to minimize, we should minimize post-processing, yes, because we need to remove the support structure and spend less material, because support structure, it's the same material as the material for main product. And we should and we need to increase the density, yes, because the main problem of additive manufactured parts, it's leak density, because it's a specific of production, some physical aspects of forming these types of product during the melting process. If we have this decision, yes, if we have these rules for design optimization, we would like to use additive design, and we can say that we realize additive design, and we can make this design because we know about the functionality of our product, we know about the specific of our process of manufacturing, yes, and we have some specific software for modeling and for engineering. Additive design, yes, some challenge how to make a good, appropriate product for our engineering task, yes. We have some idea, yes, because we know some functionality parameters of our product, and in traditional way we would like to separate our functionality, yes, because we in general we use assembly operation to combine separate parts for better functionality. Yes, but today, using additive technology, additive manufacturing, we can optimize, and we could not use separation. No, we can realize additive solution, additive design. Yes, and you know that we change the form. We use some organic forms in order to reduce the weight of these parts. Yes, for reduce material utilization, and we can produce new type, yes, a new design of our product. Additive design, yes, we know that our products need to work with some flows, air flows, water flows, yes. It's make some constraints for this design, the form of shapes, the form of holes, yes, because we need to use some we need to we should meet the requirements of this performance by modeling a good, a thing or high, yes, wall thickness in order to meet the requirement of functionality, yes, because in these tubes we see that water flow or gas flow, yes, realization. What about optimization of this geometry? Yes, in the first step, and this is the second step when we would like to optimize. Uh, how we can optimize? Yes, we should use, for example, some bionic or organic form. Yes, but in traditional way. Yes, if we would like use thin walls, it's not good for flows. Yes, it's some insufficient decision. That's why we use some modeling in ANSYS, for example, yes, in order to check the geometry parameters of our redesign and optimize construction for working condition of our product. We use simulation, CAD preparing, and additive manufacturing parameter. It's a combination of pre-processing in order to make a good appropriate part for utilization. Yes, and what about comparing conventional traditional technology and additive? You see that we reduce the weight, yes, and make our part more functional. What about their technology? The direction of technology. Yes, if you remember, I told her that this company, feed company, Additive Manufacturing Group, used the different philosophy of production. Yes, additive manufacturing for engineering. Yes, additive manufacturing for volume production, for customization. Yes, for medicine with quality, and additive manufacturing for prototyping. In this case, yes, what kind of philosophy they used? With engineering, yes, because we have an idea of our product. Yes, so we know about input data and working conditions of our product. We realized some engineering process. We use some engineering tools such as ANSYS and CAD softwares. Yes, we realize CFD simulation. It's a simulation of working process inside this product. Yes, we topology optimized the product, the design, in order to make it more economical for our customer. Yes, or not for customer, maybe for own application, but more economical because we reduce the material, the waste, the time, and the cost of production. And for example, if we would like to use specific material such as titanium, yes, and you remember this type of material, titanium powder, titanium alloys are very difficult to cutting, yes, for CNC machining. It's impossible for use in prototyping because the manufacturing of these types of materials so expensive. That's why using additive manufacturing, such as selective laser melting, is a very good decision for these types of materials. Another case about additive manufacturing products. Yes, you remember about the philosophy of production of feed company, feed prototyping and feed production. What about the first, prototype? If we have some idea, we would like to make the prototype of this idea in order to check our decision and check some performance of our parts. Yes. What about the production? If you would like to have topology optimization, yes, and use additive manufacturing, we would like to use this type of product, yes, redesign topology optimization in order to make the best performance with most economical technological process. And for volume, yes, if we would like to produce for mass production, we would like to make this product. And further, you will look the video about this case study. What about design and prototyping? Yes, if you use the specific software such as ANSYS, yes, you load your design, traditional design, conventional design, yes, you have the different variants of optimization, and you would like to select a good for your implementation, for your decision, for your industry, for example, yes. Optimization, we modeling some deformation, some stress during the working of this product, which is optimized in this software, yes. And then we should simulate the process of production, the process of melting metal powder by laser beam. What about the workflow? If we use optimization, topology optimization for additive manufacturing, we need to prepare our 3D model, yes, build job preparation, yes, and you see that we pack the different type of product on the one building platform. The process of melting, yes, and you see that we can use not only laser beam melting, we can use electron beam melting, and this is specific technology for titanium alloys. After that, we need to use post-processing, yes, and you see that we make some support structure in order to produce overhand parts, and then we need to cut this surface, this support structure from these surfaces. If you would like to produce a volume, a mass product, we need to realize the same steps. It's redesign, select the good variants of optimization of our product, yes. We need to optimize in ANSYS the form and the shape of our product, and simulate the working conditions in order to eliminate some form deviation, some defects during utilization of this product, and simulate melting process in order to produce high quality product. What about some cost and economical aspects, yes. If you would like to reduce the cost, yes, we need to standardization of our workflows, because if we will change our products before printing, yes, we will spend more time for engineering. That's why we will increase the cost. But if we will use a standard, optimize one's product, yes, we will reduce the cost for later printing, for further printing, unfortunately. What about it's the same workflow, yes, and you see the component, yes. It's the different design from prototype quality and volume, yes, because we need to save some materials for mass production, yes, and to pack more the same parts on the one building platform, yes, because we produce for volume, yes, it's a volume production. That's why we position only these types of products. It's the same. It's optimized by topology, yes, organic structure, but it's a not a full topology optimization as previous example, yes, because it's only for check the decision for prototype for idea, yes. If you would like to realize these brackets for volume for mass production, we need to use a more simple form in order to pack more parts on the one building platform. It's for economical aspects, yes. And we printed and they printed these parts on the building platform and the post-processing, yes. And you see that we have less support material, yes. Why? Because we need to reduce the time of production, because it's for volume, yes, it's for mass production. We reduce support structure, we reduce the very complex shapes for make easier post-processing, yes, in order to save time and money for volume production. And it's some summary and comparing about prototype decision, yes, quality prototype decision, and volume production. It's a normal if we use the different material in the step of prototype, because you would like to check, for example, some geometry, some assembly behavior, yes, some not mechanical parameters, yes, because if we would like to check mechanical parameter, we need to use the same material, yes. What do you think about this comparing, yes? The type of manufacturing philosophy for prototype, for additive manufacturing and quality, and additive manufacturing for volume production, yes, is depend on the lead time, yes, the unit cost, and the material utilization, yes, because if you would like to produce only prototype, yes, we can do it more quickly, yes, it's a faster prototyping. If you would like to produce a quality and very attractive for our investor, yes, and maybe have some certification of this process and material, we can spend 2 weeks, for example, for production, yes. If you would like to produce for volume, for mass production, we need to save our time, yes, and money cost for per one unit, yes, and reduce the volume, because if we reduce the volume, we will increase our profits from selling our products. Yes, it's the number of parts, 720 parts in volume production. It's the philosophy of feed company, yes. The form, their optimization, design optimization, yes, is dependent the aim of your production, yes. If you would like produce only prototype to check your idea, yes, you can realize this workflow, yes, it was the first example. If you would like to make some quality tests or measure or check the accuracy of your product, yes, maybe you would like to show this part for your investors, for example, yes, in trade, in market, you would like to use the second way of production, yes, It's maximum topology optimization, yes, but we reduce the support structure, we reduce the weight, and we reduce the cost per one unit. And if your target is volume production, yes, you need to realize the third way of manufacturing. You would like a minimum optimization, minimum minimal support structures, yes, in order to save time, time for printing, first of all, save time for post-processing, yes, and make it simple post-processing of this number printed parts. And I would like to show some video about Fit company. Yes, it will deal with 3 steps of manufacturing, yes, and you will know about design guide rules because it's very important for additive manufacturing.
High-quality products made of plastics and metals for the widest variety of applications and industries, including automotive, medical technology, aviation, and mechanical engineering. Redesign. This example demonstrates the ability to significantly reduce the weight of an automotive bracket made of aluminum. Here we have a conventionally manufactured part made of formed steel. It's easy to understand that additive manufacturing of this conventional design in large volume makes no sense. If we wish to produce this part in a truly cost-efficient way, we have to implement a number of design guidelines, especially if we wish to also improve the part by significant weight reduction. In other words, we have to incorporate new tools that additive manufacturing provides and allows for. With this goal, we at FIT have invented ADM, that is, Additive Design and Manufacturing. It means that we strive to put a completely new design language into practice, and one that improves the manufacturing process too. Incorporating ADM also allows for the reduction of post-processing, which brings a number of advantages with it. We only want to use material where it's actually needed. Furthermore, it's also important for us to position and orient the part in an optimal way inside the build chamber. This will ensure production of the highest quality part to meet the customer's needs and specifications. In order to implement this cumulative know-how really well, it takes a great deal of engineering experience and expertise, both of which we provide to customers here at FIT. The starting point for redesigning the automotive bracket is to analyze the conventional steel part. The dataset is loaded into a CAD system in order to define the design space needed for topology optimization. Using a program for optimizing topology, a number of design variants with reduced material volume are created to meet given sets of loads and forces. Using finite element analysis, each design iteration is then tested and evaluated with respect to the corresponding stresses. In the next step, the topology-optimized design is then further optimized to meet the requirements for cost-efficient volume manufacturing. The complete optimization process requires several iteration cycles. Different prototypes are physically produced to study and identify the true optimal solution. The final version of the CAD model is designed and evaluated to reflect all requirements and boundary conditions. A successful final test of the prototype completes the design process. By changing the bracket material from steel to aluminum and using the resulting additive design, we were able to create a part that weighs just 203 grams, requiring only 3 grams of support material. We achieved this through a specifically tailored additive design. For example, the bracket starts out narrow at the bottom, then widens, resulting in a self-supporting geometry. This allowed us to only use a minimal amount of support material along the bottom edge of the bracket that contacts the build plate. We eliminated the support material for the lateral attachments as we were able to modify the angles in such a way that avoids the need for support structures. In addition, we've removed material and the corresponding weight in areas with low stress, such as here in the rear flange section. The resulting design is quite unique, but for us it was a great opportunity to remove a significant amount of material. The strut sections were designed completely hollow, and the loose metal powder was blown out through the holes along the sides after the part was completed. In order to save even more weight, we designed out more material in the rear section. After all engineering steps have been completed, the support structures are skillfully added during data preparation, and the final production-specific adjustments are made. The design of the serial part aims to achieve a maximum packing density in the build chamber to reduce manufacturing costs as much as possible. Once the prepared data have been transferred to the specified machine, the build job is started. In the case at hand, the large size of the build envelope of the SLM 500 system allows the manufacturing of 15 identical parts within one build job. The quality of each of the single parts produced is assured by a wide array of monitoring and evaluation methods during and after the laser melting process. FIT's factory monitoring system, a proprietary development, displays the parameters for each individual system in real time, allowing for sophisticated statistical analyses afterwards. Once the build process has ended, the build cylinder is removed from the machine. The reusable metal powder is separated in the depowdering station. By using exchangeable job boxes, the system is immediately available for the next build job. In volume manufacturing, it is essential to assure the constant quality of the serial parts. Reliable quality can be achieved by measuring and evaluating the parts, considering all tolerances specific to the build process involved. The subsequent post-processing steps include various advanced manufacturing procedures, such as the CNC milling of holes. Final machining of the serial parts occurs after removing them from the substrate plate. Depending on the customer's requirements, QA may include the advanced measuring of each individual part. FIT production is certified in compliance with ISO 9001 for our general quality management, with EN 9100 for aviation and aerospace, and EN ISO 13485 for medical products, and fulfills the requirements set by the FDA in the USA. In addition to traditional material testing methods, such as the control of cross-sections under a light optical microscope, FIT also employs an in-house CT scanner to verify and confirm the quality of inner structures by fast and
Okay, let's discuss the video about the case studies in FIT company. Yes, FIT Additive Manufacturing Group. First of all, what they realize? Yes, they developed some design guide rules for optimizing the parts that design a 3D model. Yes? Yes. The main idea of their technological philosophy that we can improve technology only using additive design. Yes? Yes. And in order to improve our technology, yes, our process, we need to analyze our conventional, traditional design, or analyze the performance of our product and redesign or make additive design. Yes, and they use 3 steps for manufacturing. First of all, preparing. Yes, it's involved topology optimization. Yes, it's selection the different design variants. It's finite element analyzing in order to modeling some distortion, deformation, and stress. Yes, and if you would like to produce prototype, yes, it's their design philosophy, philosophy of additive manufacturing. Yes, use the different steps, the different ways for different targets. For prototype, yes, we need to meet a cost efficient, yes, in order to check our idea. Yes, we can make some tailored design. Yes, and the task of this step in which? In that? In what? Uh, in minimal, yes, it's minimization, the support materials, yes, it's some modification and try to modify the angle of position of our parts, our goods on the substrate or building platform, yes. And if you would like to volume production, yes, for mass production, we need to pack the maximum parts on the one building platform on the substrate. Yes. What about the second step in the process? Yes, they use a new types of machine, SLM 500, which uses 2 or 4 lasers in order to increase the productivity, and they can monitoring the SLM parameters. Yes, after that we need to remove extra metal powder, yes, for utilization, again utilization after sieving, and separate parts in order to cut the supports. What about the control? Yes, what about the control? We need to measure our parameters, yes, geometry and quality, for example, surface and hardness, and evaluate these parameters with prior parameters that we need to use for preparing, yes, input parameters and output parameters. It's some evaluation and verification, yes. What about the third step? Post-processing. Yes, it's some treatment, for example, heat treatment, yes, or some mechanical process using CNC machines for milling and cutting. Yes, and in order to check and use the different standards, we need to inspect our material, yes, our sample, which we produce together with our product, and check cross-section by the different equipment, inspection equipment, and tomography in order to check the density of our product. Yes? Yes. What about another idea for feed company? Yes, the main idea, not another, the main idea. It's additive design. Yes, uh, it's shape generation. It's transformation of our geometry and forms. It's topology optimization. That's why we need to look the next video. process of transformation, some traditional design to additive design. Yes, and you should know that what kind of software we can implement in order to optimize our model, our design. It should be mentioned that we need to make more engineering, yes, before printing. It's not very simple process to print. It's very difficult and it's challenge for engineer how to change the design to additive design, yes, and printed them. We can use the different types of structures such as lattice structure, yes, it's for lightweight. And this is an example of printing the structure. We should modify 3D model for processing for CNC machining because it's very difficult to produce such complex shapes. What kind of software? It's NetFab. NetFab is for preparing 3D model for printing. Remodeling the process of slicing. Yes, it's modeling layer by layer process. And in this software, we can prepare file for printing for 3D machines. Power inspect we use for inspections, for measurement. If we use heat-resistant materials such as implement, we need involve heat treatment in the manufacturing process. And very important to control to check the density. That's why we should use tomography for inspection. And for precision part, we use CNC machining. Before real work, we need to modeling, yes, make some digital model and simulate this process. After that, we can realize it in real material. Okay. What is the main idea of Fit Company? Yes, it's additive design. For what? What's the main goal of this redesign for this engineering? Task one, yes, it's for minimize some residual stress when you would like to part orient, because it's concern build direction, and build direction is defined that axis. It's need for make the process sustainable and more precision. The main idea, the main target of designing and preparing before printing, it's select a good, appropriate part orientation and build direction, because we need to reduce internal stress, yes, during the process, because we deal with high temperature of laser beam and metal powder, yes, and to reduce the volume of support materials. Yes, and you see that we have some overhand surfaces. We need to make this support structure. What does it mean? If we have support structure, yes, we should to cut them after printing, yes. That's why we need to add additional post-processing. It's a cost, it's a time. And this is the quality, because these surfaces will make with post-processing. Task number 2. If we select a good build direction and part orientation on the substrate, we can control melt pool. Melt pool is a physical process of connection between laser beam and metal powder. Yes, and the quality of melt pool will define the quality of cross section and the quality of surface and part in total. Task number 3. If we would like to make precision and high quality product without post-processing, we would like to use unsupported design. Yes, and you see the design guide rules for overhand surfaces. Yes, if we use this angle, yes, 45 degrees, we don't use support structure. But if we print horizontal surfaces, yes, we need to make this structure, this support material. And you see that if when we use not good angle of position our parts between product, between sample and substrates. Yes, we have some failures and damage during the process. It's very important for designing, for engineering. Yes, select a good position, build direction in order to reduce stress during the process, reduce the support materials, yes, and make a sustainable melt pool formation during the process. And I would like to show a video about this process, how to select a good part orientation in order to meet these requirements. It's build time, volume of material such as support material, yes, and stress elimination. This is the example of more support structures in their part in the sample, yes, and if we change the geometry, yes, the angle of position add material, main materials, yes, we eliminate this support structure. very important to select a good part orientation. Yes, it's a vertical position for these brackets. Yes, because we don't use support structure, support materials. But if we will use only vertical position, yes, we will increase what we will increase. First of all, the time of production. Yes, because we need to make more layers. Yes, and what else? The cost. Yes, and maybe the mechanical properties. But if but you will know about the dependence between part orientation and build direction and mechanical properties in your master's class. Next time you will repeat these activities, these cases that you looked in this video. You will prepare a 3D model. You will topology optimize this design, the design of some engine components. Yes, and check some properties in ANSYS software in order to select and make a good choice for manufacturing. Yes, and you will compare the different position and how much support materials we need to add in order to produce the same product. Yes, and what kind of materials we use, what kind of type of this support structure we can implement, and what is the cost of this modification. I would like to ask you about softwares in these videos. Yes, what kind of software they used for additive manufacturing? Yes, for preparing, for machining. Yes, and for inspections. Who remember? For preparing, for modeling additive manufacturing, what kind of software? NetFab, yes? When we can redesign to cut layer by layer our 3D model, yes? And prepare file for printing, yes? It NetFab. When we select our equipment, our machines, yes? Select parameters of melting and prepare the design. Yes, it's not fab. If you are interested for this engineering, for this design activities, you can load this software in internet. It's Autodesk company. Yes, and check this software for optimization. What about CNC machining? Yes, it's a power mill. Yes, we're modeling the traditional technology, cutting, milling in this software. Yes, after printing. And what about inspection for measure? They use power inspection. Yes, inspect, power inspect. We Yes, you can get a free student use software, and I will send a link how to download this software in WhatsApp chat. Okay, it's main idea of additive manufacturing, because additive manufacturing is still expensive technology. Yes, because we use expensive equipment and metal powders to mod the main idea, make some modeling and preparing and simulation before printing. Yes, we need to check and we need to prove our technology solutions before printing, because before involve our money in manufacturing process. That's why we use the different types of software for modeling and to select optimize technological parameters. But as you mentioned, yes, noticed not technological parameters only. Yes, it's the quality is dependent on part orientation. Yes, how many parts we affect the building platform on the substrate. Yes, what kind of material we use, what kind of machines we have, how much lasers. Yes, it's multi-parameters technical task for modeling additive manufacturing process. Yes, because it's very important to understand the physical process of melting metal powder. Yes, and understand how our engineering, which involve additive design, part preparing for printing, part orientation, adding support material, yes, and select technological parameters, yes, is depend on quality, for example, yes, the common word for performance characteristics of our products. Yes, and you would like to make some correlation analysis, yes, between these parameters from engineering, yes, and parameters of quality, mechanical properties, roughness, hardness, yes, and specific performance or which performance which deal with working condition of these parts. Okay, after our lectures and master's class this week, yes, we will try to write this correlation formula to get the link between these parameters from designing, from engineering, yes, and link between parameters from engineering and parameters of our parts, functional parameters of our parts. Okay. Okay. Maybe you have some questions for today material. I know it's very difficult to understand so much information about additive manufacturing.
I have a question. Hello.
Yes.
The laser process of creating additive manufacturing. Can you explain again how it's done? I can't really get it.
A workflow of the process of additive manufacturing. The
No,
steps.
no. As in, yes, the steps of how it is done.
Okay, the steps of additive manufacturing or workflow, yes, it's consist of main 3 steps, yes, preparing, processing, and post-processing. And I will show this slide from my presentation. You see the slides?
Yes.
First step, preparing. Yes, when we deal with optimization, yes, topology optimization or redesign our products for edge design rules. Yes, we need to check some functional parameters by finite element analyze. Yes, and meet some requirements, for example, for cost efficient, for tailored design, for technology limits its concern angle position, yes, and if we deal with volume production, mass production, yes, we need to pack the maximum products on the one substrate, yes. It's the first step to optimize, to check, to simulate the process, yes, and packing our parts, our 3D models on the building platform, and form a STL file for 3D printer. And you will get this step at your masterclass this week. Second step, some process, yes. It's a laser melting process or direct metal deposition. It depends on the kind of technology of additive manufacturing. Yes, we need to monitoring the process in order to control the parameters. What kind of parameters? Laser power, yes, scan speed, hedge distance, and layer thickness. After that, when we finish, we need to remove extra material. It's a metal powder which did not melt, and separate our parts from support structure. Yes, because if we print overhang surfaces, yes, we need to make some supports. Yes, and after printing, we need to cut this support structure, support materials. We need to control to evaluate accurate and quality. Yes, and step 3, it's post-processing. If it's need for your requirement, yes, for medical post-processing, for additional measure by this standard, yes, 910, and for material inspections. It's generally for aerospace application, because we need to print in one building platform with part a sample, which then we will investigate material inspection and control the geometry. It's 3 main steps of additive manufacturing: preparing, process, and post-processing. If we would like to realize, optimize, improving, exciting technology, yes, we need to make additive design and use design guide rules. It's very important, and this is the main research in this field in additive manufacturing development. How to create appropriate design, additive design, in order to realize this technology for most economical official, yes, for meet the requirement of functional parameters of our products, for market demand, for example, for customization, for specific conditions such as open space, for example. Yes, if you would like to print some devices or component which need to launch to space. Have you any questions about the steps of additive manufacturing process?
No, I understand.
Okay, and the next slide is demonstrate the steps in feed company. Yes. The same 3 steps, yes, and what kind of activities we need to do in order to realize these steps. Okay. Another questions? If you don't have any questions, yes, I think we can finish today, yes, and continue next time, and you will make your work class. Yes, and discuss and try additive design in our lab. If you have some questions not in our class, you can write in WhatsApp chat. Yes, and I can send maybe material if I have about your questions, your interests in additive manufacturing. Maybe you would like to know more about plastics or biomaterial technology. Yes, for example, bio 3D printing. Maybe you are interested in space application of additive manufacturing. Maybe some engineering and build some construction. Maybe in building some houses and design forms. I don't know what else. If you have some ideas, for example, you would like to design and something print, yes, you can write us by chat, yes, and we can send some material and discuss, not in these hours for study. We are open 24 hours per 7 days a week. For your interest in this study. I'm glad that you're coming this evening for this lecture, and I hope see you next time in your master class.
Yes. Sorry. One more question. Please, during our time of trying to practicalize whatever we learned, how can we do that since we are not in Russia?
Okay, you will some practice work, yes, and we will send a link for software. You need some registration as a student of some modern university or your own university, yes, and by Zoom we will try to repeat the activities that Anton, it's our specialist in additive manufacturing modeling process, and you will together make some modeling and optimization of 3D model.
Okay, thank you.
And if you would like to print something by SLM or FDM technology, it's a plastic, yes, we could discard this and print it in our lab, and then we can send by mail to you.
That would be so good.
Okay. Okay. Have a nice evening, and I hope see you next time.
Bye bye.
Bye. See you. Thank you.